Hello, my name is Samantha, and welcome to the 9th lesson in the Girls in STEM Java curriculum. Last lesson, we talked about methods, and we made a few of them. Today, you'll be introduced to classes. I'd like to introduce Sarah, who will be the instructor for today's lesson.
Hello and welcome. My name is Sarah and I will be your instructor for today. Today we'll be learning about classes, objects, and constructors. We'll start our lesson with a review of last week's lesson on methods. We'll start with a review of method declaration. We'll first have the modifier, which in this case is public, then the modifier is followed by the return type, in this case int, method name, which we've called max, and the parameter list. Here they are integers x and y. Inside our method, we will have the code which forms the body. Please note the order of the words in green. Here's a quick recap. This is the header for all of your programs so far. These methods are called main methods. Public is a modifier and it makes the method accessible by other classes. Static means that the method is associated with the class itself, not with any particular object created from the class. Void states that this method does not return any value. Main is the method name, and string args state that the main method takes in a string array called args. Now we'll work on some warm-up problems. We'll need to set up Replit for all of our warm-up review and practice problems today. We can start by creating a new Replit called Lesson 9. You may pause the video here if you need to. Our first question asks us to write a public static method called add1 that adds 1 to an integer n and returns the sum. Then print the sum in the main method. The main method should take in n as a parameter. The second question asks us to copy method add1 from warmup number 1 and paste it under the original method. Rename the second method to print add1. We want to alter this method so that it prints the new number directly in the new method, not the main. It should not return anything. We should call the print add1 method in the main method. We'll go over the solutions in a few seconds, so please pause the video here if you need to. We want to write a static method called add1 below the main method. For our method header, add1 will take in a parameter, integer n, and will return an integer value. Then we'll add a return statement that just adds 1 to the number passed to the method. In the main method, we'll call the method add1, pass the number, and print it. For question 2, we want to create another method called print add1. We can copy paste our add1 method, but we will have to make some changes. We need to first change the retire type from int to void, because we do not want to return any values for the print add1 method. Inside the method, we want to write a print statement that prints n plus 1 in the place of the return method. Finally, in the main method, we call print add1 and pass it an arbitrary number. Here we've used the number 7. Now we'll start today's lesson on classes. A class is a blueprint that can be used to create objects and contains a set of properties or methods that are common to objects of that type. Inside your methods, you can have parts such as constructors and methods, which we will talk about in greater detail later. For the most part, all of your code will go inside a class. We'll look at the code on the slide in greater detail. We have the main class, and inside the class, we have a main method. We can also have other methods inside the class. Another topic we'll be going over today are objects. An object is an instance of a class. They are created similar to how variables are created. In fact, variables are objects. Java is an object-oriented programming language, so everything in Java is an object. We can take a look at an example. Here, we're creating an object of the scanner class, and we've called it myScanner. The general syntax for creating an object is to first declare the class name, object name, the new keyword, and the class name with parameters. Note that classes are not limited to integers, scanners, and strings. In our next example, we're creating a bike object of the bicycle class. Also, make sure you have the new keyword. We'll also introduce constructors in this lesson. A constructor is a set of instructions that tells the computer how to create an object or instance of a class. The constructor will have the same name as the class. Constructors initialize all instance variables. If a constructor has no parameters, it is called a default constructor. However, there are also constructors that can take in parameters, which are called alternate constructors. Constructors initialize all instance variables. There can be more than one constructor per class, as long as there is a different number or different type of parameters. Note that constructors also do not have a return type. This means there is no void, int, boolean, or other return type. We omit it entirely. Let's take a look at an example. We have a class called aClass, which has the instance variables of var1 and var2, both of which are integers. The default constructor on the left does not have parameters, and it assigns a value to each variable. The alternate constructor on the right has two parameters, integer 1 and 2. Then we assign 1 to var1 and 2 to var2. Now, we'll take a look at how to make classes in Replit. Typically, we only write one class per Java file. Still, we'll go over how to make additional Java files. In the left panel, there is a list of all your Java files. When you create a new project, there should only be one class called main. To create a new file, click the button directly to the right of Files. Then you can program a new class with your new file. To understand how to use an object, let's look at a dog as an example. There are three primary aspects we need: the state, behavior, and identity. We need the state, or the characteristics or properties of an object, which are also the variables. More specifically, variables created inside a certain class are called instance variables. The behavior is represented by the methods of the class, and the identity is the unique name of the object. Now let's think about the state, behavior, and identity of our dog object. The state could include the dog breed, age, and color, which are also the characteristics of the object, which is the dog. Behaviors include bark, sleep, and eat, which are methods or actions the dog can take. Here we have 4 identities, which are the unique names of each dog object. Well, how does this translate into code? Well, we first create a class called dog. We then state the attributes or instance variables below, which are string breed, int age, and string color. Our default constructor is public dog, which contains the default attributes. For this example, we use Samoyed, age 4, and white colored. We then have an alternate constructor, which allows for more flexibility in the attributes. Lastly, we have the class behaviors or methods. We can create 3 separate methods, each printing out the corresponding onomatopoeia. Just like when we call methods like substring or println, we can call methods from a class like dog from the main class. We would do that by using object name.method. If we wanted to call the bark method from a dog object named Maya, then we could write dog Maya equals new. Then on a new line, dog parameters, and then Maya.bark. Now let's write a class. We'll create a new file in Replit on the left-hand side and call this car.java. Our car class will have instance variables color, number of doors, number of seats, and max speed. We'll have an alternate constructor that takes in the instance variables above. You do not need to write a default constructor. Finally, we'll also have 3 methods: drive, park, and beep. Then in the main method, create a car object called Lightning McQueen and test your methods. Your method should print a statement that shows it has been called. Our sample is lightningmcqueen.beep, which prints beep, beep. Please attempt the problem first before looking at the solution. You can pause the video here if you need to. We'll create the car class inside our car.java file. We have our instance variables, color, number of doors, number of seats, and max speed. Max speed can also be an integer or a long. Then we can create our alternate constructor that takes in 4 parameters, string c, int num doors, int num seats, and double max s. We assign each of these values to the instance variables. Remember that the instance variables and the parameters of the alternate constructor need to have different names. Next, we would create all of our methods. Each method has the same structure. We'll have public methods so that they can be called later. The methods don't return anything, so our return type will be void, and we have no parameters. Finally, we will make our main method in the main class. We'll create an instance of a car called Lightning McQueen and the variables red, 2, 4, and 224.3. Then we call each of the methods to make sure they work. For our next problem, we are asked to choose an animal to create a class for, similar to our previous dog example. What kind of things do we need to think about? Brainstorm different characteristics and behaviors of that animal, including age, height, and sounds. Please attempt the problem first before looking at the solution, and pause the video if you need to. Here is the key. We'll first create a class named after your animal. Here we used a giraffe in this example. We have our instance variables, spot, height, weight, and favorite food. Then we can create our alternate constructor that takes in 4 parameters, int s, long h, long w, and string ff. We assign each of these values to their corresponding instance variables. Keep in mind that the instance variables and the parameters of the alternate constructor need to have different names. Next, we would create all of our methods. Each method has the same structure. We'll have public methods so they can be called later. The methods don't return anything, so our return type will be void, and we have no parameters. Finally, we will make our main method in the main class. We'll create an instance of a giraffe called Gary with the variables 64, 16, 1000, and acacia trees. Then we call each of these methods to make sure they work.
Hi, I'm Alexis. Thank you so much for watching and congrats on completing your 9th Girls in STEM lesson. If you have any questions, comments, or concerns, please feel free to reach out to us at our email ccagirlswhocode@gmail.com or comment down below. We wanted to thank the following on the production team for all of the hard work that went into today's lesson. All of the slides, videos, and problem sheets in the series are available on our website as well as the description below. I hope you'll join us again in our next lesson, where we'll add on to what we already know about methods.